Hello everyone, Andy Klein here with a little bit of a brain teaser for you today. Does anyone think they know why some planes have these grooves cut in the sole, in the bottom? There's a bit of a better look. Well, I haven't researched this at all, but I can tell you one thing that these grooves really are not doing, or doing only very minimally, and that is to reduce friction when the plane is used. They're just not reducing friction. Blasphemy, you say? Well, I'm going to try to convince you. So I rigged up this system that will let me look at the force of dynamic friction as I pull this board across my workbench. And I weight it down with some heavy nails just to get a decent friction force. And I end up with, there's 3.2, bounces around 3.3, briefly at 3.8. You know, it's not a constant thing, but it ends up spending most of its time in kind of the mid to low threes. Now I take that same board to table saw and remove probably about 75% of the material on the bottom, leaving just some thin runners to do an even more extreme simulation of what's happening on the sole of the plane. So there's a closer look. This is going to be sitting on just those thin strips, so most of the surface area has been removed. But lo and behold, when I do the friction test, we're in the same range, bouncing around between 3.2 and 3.4. Removing that wood hasn't changed the force of dynamic friction. So what's going on here? Why are we getting this somewhat non-intuitive result? Well, let's take a look at the physics. If you have a plane sitting on a surface, it's being acted on by four forces. There's gravity and the force from your hand pushing down. There's a normal force from the board pushing up. There's also a force from your hand pushing forward. And there's a friction force pushing back. Now, if acceleration equals 0, so the plane's moving at a constant speed, which is a simple situation, then all these forces are in balance. The normal force from the board is equal to gravity plus your hand pushing down, and the force of friction is equal to the force from your hand pushing the plane forward. And now for the important equation, how the horizontal forces relate to the vertical forces. So the force of friction is equal to the normal force times a coefficient of friction which is unique to the two materials involved, in this case metal and wood. So importantly, what's not in that equation? Well, surface area. There's nothing that changes if surface area goes up or down. But that's really kind of just restating the same thing that my little example does. It doesn't give any more intuitive understanding. Well, why is that? Well, we can write the equation for the friction force a little bit differently in a way that does include area. We could say friction force is equal to pressure times area. This is just as valid a way to express it. And this second expression is still in agreement with the first one because pressure is equal to force divided by area, in this case the normal force. We'll just rewrite area times the coefficient of friction. And now you see that areas just cancel out, goes away, and you're left with the same equation in the first place. So there are really two ways of stating the same thing. And now we can start to understand why area doesn't have an effect. Because as area goes down and the force pressing down on the plane stays the same, the way you're using it doesn't change, then the pressure goes up. So let's say you cut area in half, you're just going to double the pressure and the force of friction will be unchanged. And that's what you saw in the demonstration that I just did, even when I reduced area by much more than 50%. So hopefully you're convinced that the effect on friction is slim to none for these grooves, but that still leaves a question of why are they here? Well, I think maybe there's potential for any kind of small bit of dirt, grime, sawdust, whatever, to fit into those tracks and not mess up the planing, maybe. I'm just kind of speculating here. I think probably more likely they're here so that if you need to flatten the sole of the plane, you just have less material to take off and it takes less time. That certainly could be the case. But any plane experts want to tell me otherwise, certainly open to hear about that in the comments. Hope you found this interesting. That's all for now.